Today we're going to be discussing how to use the sum and difference identities to simplify trig expressions. So before I was only able to ask you for like sine of 0, pi over 4, pi over 3, pi over 6 in all the different quadrants. But now we're going to notice that we're going to be able to find other angles using pi over 6, pi over 4, and pi over 3. We're going to start with the cofunction identities, and the reason this works is because if I have an angle here, this angle, well, it's a triangle, so all the angles have to add up to 180. Well, this is 90, so that means this angle and this angle must add up to 90. So if this angle is theta, this must be 90 minus theta, or pi over 2 minus theta. So let's call this A, B, and C. So if I asked you for cosine of theta, you would tell me it was B over C. But if I asked you for sine of this angle, do you see that you would also get B over C, opposite over hypotenuse? That's why these work. So if I asked you for sine of 30 degrees, and you already knew what cosine of 60 degrees was, you would know that they were equal to each other. If I asked you for tangent of some angle, you can write that as cotangent of 90 minus that angle. If you wanted to write that in terms of radians, you would get this. If I asked you for cosecant of 40, you would get secant of 90 minus 40, or secant of 50 degrees. If I asked you for cotangent of pi over 5, you would get tangent of pi over 2 minus pi over 5. Get a common denominator so you can simplify. I have 2 and 5, so I'm going to choose a denominator of 10. So times 5 minus times 2 times 2. And I'm going to get tangent of 3 pi over 10. The next type of identity that we're going to talk about is the sum and difference identity. So first we're going to work with sine of an angle. So if you want to see the explanations actually written out for why these work, feel free to check out your textbook or ask me. I can show you the proof, or at least a loose proof for now. This piece right here says if you break up your angle into two familiar angles, so if you know sine of your first angle, if you know cosine of your second angle, you'll be able to find sine of the sum of them. So your goal is to kind of break this up into either a sum or a difference, and then you can use either of these formulas to evaluate it. So for example, if I asked you for sine of 15 degrees, you would say, okay, well, I know sine of 45 degrees, and I know sine of 30 degrees. Do you agree that sine of 45 degrees minus 30 degrees is really just sine of 15 degrees? If you can break it up like this, you can rewrite the formula. So you could write it as sine of 45 times cosine of 30 minus cosine of 45 sine of 30. And then you would just evaluate. So figure out what each of these equal, multiply these together, and then take the difference. For this example, your A would be 45 degrees and your B would be 30. Something that I think is going to help you is if you have your familiar angles. So our first familiar angle is pi over 6. Our second one, pi over 4, and then pi over 3. So if I was trying to create a common denominator with 6, 4, and 3, I would think of 6. 6 doesn't work for 4, so then I would go to 12. 12 works for all three of these, so I'm going to make them all have a denominator of 12. So here it's times 2 times 2. Here it's times 3 times 3. Here it's times 4 times 4. When you're trying to find the sum or difference, using these purple pieces will help you come up with that much faster. So for example, if I ask you to find sine of 7 pi over 12, looking at pi over 6, pi over 4, and pi over 3 is rather difficult to find the sum. But if you look at the common denominator, 7 pi over 12, you can easily see that you could just add these two together, which really means you're adding pi over 4 and pi over 3. So I can rewrite this problem as sine of pi over 4 plus pi over 3, because remember, pi over 4 plus pi over 3 equals 7 pi over 12. So now I have my A and my B, and then I'm going to assume this is addition. So my a for this problem would be pi over 4. My b would be pi over 3, and I would be taking the sum with sine. So I would be looking at this equation right here. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Now I want you to have your unit circle or your triangles readily available. Pi over 4, where can I find that on the unit circle? Well, that's in the first quadrant. The ordered pair would be square root of 2 over 2, square root of 2 over 2. And pi over 3, that's also going to be in the first quadrant. And you're going to get 1/2 square root of 3 over 2. You're going to get the same answers if you use your triangles. So sine of pi over 4, just take the y value. So I get square root of 2 over 2. What's cosine of pi over 3? Well, it's the x-coordinate, so I'm going to get 1/2. Bring down the plus sign. What's cosine of pi over 4? Well, square root of 2 over 2. What's sine of pi over 3? The y value, square root of 3 over 2, right? Remember, why is it just the y value? Because your r is just 1, so it's really y divided by 1, so it's just going to be the y value. Now we're going to simplify, so we're going to get square root of 2 times 1 over 2 times 2, plus square root of 2 times square root of 3 over 2 times 2. And I can combine these because they have a common denominator. Do not use a calculator. Leave your answer as is. See if you can pause the video here and try to rewrite sine of 15 degrees as the sum or difference of something that you know. So I'm not just going to write sine of 7 degrees plus 8 degrees, right? I don't know what sine of 7 degrees is. I have to use angles that I'm familiar with. Okay, when I tried this problem, I got sine of 45 degrees minus 30 degrees. 45 minus 30 is positive 15 degrees. So I would choose my A value to be 45. I would choose my B value to be 30. And then that must mean I would be taking the difference. Now, other students could do this problem and they could choose their A value to be 45. They could choose their B value to be negative 30. And then they would have to use the sum formula. So see how you should get the same result either way. Because 45 minus 30 is the same as 45 plus a negative 30. Most students would choose this first option, so that's what I'm going to use. So now we're going to be using this formula down here, because we're looking at the difference formula. So we get sine of the first, cosine of the second, minus cosine of the first, sine of the second. So again, using your unit circle, you should find 45 degrees on your unit circle and then look at the y value because you're looking for sine. So you get square root of 2 over 2, and that replaces this whole piece right here. Now what's cosine of 30 degrees? So you're looking at pi over 6, so you choose the x value. So that's square root of 3 over 2. Minus cosine of 45, choose the x value. And sine of 30, choose the y value. Now simplify. So you get square root of 6 over 4 minus square root of 2 over 4, and combine. Square root of 6 minus square root of 2 over 4 is your final answer. Use the sum or difference identity to write the following expression as 1. So notice how it looks like it's the sine with the sum in between because they're alternating sine, cosine, cosine, sine, and these values stayed the same. But what's throwing this off is this 3 out in front. So I'm going to get rid of this 3. So I factored that 3 out in front. Now I see that they're alternating, so I'm thinking of the sum or difference for sine because the sine and cosine are changing. Now, I see that we're dealing with the sum. Sine, cosine, sum, cosine, sine. The A and B values stayed the same. So it looks like this one here. So it looks like sine of A plus B. What would be your A? What would be your B? So this is equal to, this part right here is equal to sine of A plus B. And then you have to leave your 3 out in front by multiplication. So this is really simplifies to 3 sine of 4x. Now we're going to practice using the cosine sum and difference identities. Remember, when you're trying to use the sum and difference identities, you're adding and subtracting fractions, so it really helps if you have a common denominator. So if I'm looking for cosine of 5 pi over 12, most students would choose to add these two values together, which means they're going to add pi over 6 plus pi over 4. So I'd be using this top equation here. So when I'm using that top equation, it looks like my a value is going to be pi over 6, while my b value would be pi over 4. Now, do you think the answer would change if I chose my a value to be pi over 4 and my b value to be pi over 6? No, these two added together still should equal 5 pi over 12, so it shouldn't matter the order in this case. For some problems, the order does matter. So for example, if I was doing a difference problem, the order would matter. It would change the sign of my answer. So again, have your unit circle handy, and we're going to rewrite according to this top equation. So cosine, cosine. See how they're not alternating this time? So cosine of my first, cosine of my second. It was plus, now it's minus sine of my first, sine of my second. Get your unit circle ready. Now I want you to find cosine of pi over 6. These should be very quick to you at this point. So you get square root of 3 over 2. Now I want you to find cosine of pi over 4. So root 2 over 2. Minus sine of pi over 6, so it's 1/2. Sine of pi over 4, so root 2 over 2. So I'm going to get square root of 6 over 4 minus square root of 2 over 4 and just combine them. Now I want to see if you can quickly go through this next problem. So working with degrees is a little bit faster. You think, what two angles do I know that I can add together and get 75 degrees? So 45 and 30. You can also think of a difference, like if you think of a larger angle minus a smaller angle. You do not have to do these using the exact values that I choose. There are other ways to do these problems using the sum and difference identities. As long as cosine of these two angles add up to 75 or subtract to 75, I'm going to choose 30 and 45. All right, so now I see its cosine, I see its addition. So I'm going to use this top equation here. I'm going to find my a and b value. So a would have to be 30, b would be 45, and we would be using the sum formula. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. Now you just use your unit circle to evaluate. So we're just seeing how to use the sum and difference identities to find trig expressions that we couldn't find before. So cosine of 30 degrees, which is easy to find using our unit circle, is square root of 3 over 2. You should get the same answer using your triangles. Cosine of 45 degrees is going to be root 2 over 2. Minus sine of 30 is the y value. And sine of 45. So notice how a lot of these answers look very similar, because that's where we're dealing with angles kind of towards 0. So angles towards the first quadrant, like our original angles here. Do they always have to be towards the first quadrant? No, they do not. So now, are you thinking sine or cosine? Look at your identities. Well, it looks like these are not alternating. It's cosine, cosine, sine, sine. So that leads me to believe that we're going to be dealing with cosine of two angles either added together or subtracted. Since this is a plus sign, I think these are going to be subtracted. See how these do not alternate? And it's a plus sign, so I think it's going to be subtraction. So cosine of a minus b. What would be our a value here? 4x. And what would be our b value here? 7x. So we get cosine of negative 3x. If you look on your trig identities sheet, you're going to realize that cosine and secant are even functions, while sine, cosecant, tangent, and cotangent are odd functions. What that means is I can rewrite this entire thing by factoring out the negative and getting rid of it. So I can rewrite that as cosine of 3x. If the cosine function was odd, I would have rewritten it like this. But since it's even, it will simplify to this. Take a second to kind of think about this tangent sum and difference. You take your tan of A plus tan of B, and then 1 minus tan of A, tan of B. So see how it's plus, plus stays on top. See how this is minus, minus stays on top, and they alternate on the bottom. So it looks like they're practically the same. The difference is just the sign of the values. So again, think of the angles you're familiar with. get a common denominator. When dealing with radians, it is helpful to have these. So evaluate the following expression. So before, I would never be able to figure this out, right? I would not know where to look on my unit circle. I know, hey, it's probably in quadrant 4, but besides that, I don't really know much about it. I know my final answer should be negative since tangent is negative in quadrant 4. But it's hard to use the unit circle to actually see that. But if I have this formula here, I can try to make it a sum or difference of something that I know. So I'm looking at negative pi over 12. How can I get that with these quantities here? Well, I could do this minus this and get negative pi over 12, or I could do this minus this and get negative pi over 12. So there are multiple ways to get to the same correct answer. I'm going to choose tangent of pi over 4 minus pi over 3 because 3 pi over 12 minus 4 pi over 12 equals negative pi over 12. So this minus this should equal negative pi over 12. So I didn't change anything about this problem. I just rewrote it in a different form. Now, which equation can I use? I can use this bottom equation here. So I get tangent of the first minus tangent of the second over 1 plus tangent of the first, tangent of the second. So tangent of pi over 4 is root 2 over 2 divided by root 2 over 2, which is just 1. Tangent of pi over 3 is square root of 3 over 2 divided by 1/2. So it's going to be square root of 3 over 2 times the reciprocal. So it's just going to be square root of 3 over 1 or square root of 3. Over 1 plus tangent of pi over 4 we just discussed is 1. And tangent of pi over 3 we just got was root 3. Now I want to get rid of this square root of 3 on the denominator, so I'm going to multiply by the conjugate. So what do I get on the bottom? I keep it exactly the same except I change the sign. And I'm only allowed to multiply by 1, so I put it over itself. So now I go ahead and distribute. 1 times 1 is 1. 1 times negative root 3 is negative root 3. 1 times negative root 3 is negative root 3. Negative times negative is a positive. Root 3 times root 3 is 3. Over 1 times 1 is 1. Square root of 3 times 1 is positive square root of 3. Negative square root of 3 times 1 is negative square root of 3. Negative times a positive is a negative. Square root of 3 times square root of 3 is 3. So some students call it FOIL, but you're just distributing those quantities there. 1 plus 3 is 4. Minus how many root 3's am I subtracting? 2 of them, so 2 root 3. Over, these are opposites, so they cancel. 1 minus 3 is negative 2. Let's go ahead and simplify that. This divided by this is negative 2. This divided by this, negative divided by negative, is a positive. 2 divided by 2 is 1. 1 times square root of 3, so this would be my final answer here. See if you can rewrite this using similar angles or angles that you're familiar with. I see a 165, it ends in a 5, so I have a feeling I'm going to use a 45-degree angle in some way. Now 45 plus 30 is going to give me something in the first quadrant, not the second quadrant. It's too small. 45 plus 60 is still too small. So instead of using just a 45-degree angle, maybe I could try a 45-degree angle in the next quadrant. So look at quadrant 2 and find the 45-degree angle in quadrant 2. Do you see that it's 135 degrees? So now 135 plus what gives me 165? Well, 135 plus 30. I know tangent of 30 and I know tangent of 135 because of the unit circle, or by drawing a 45-degree triangle in quadrant 2. So I can rewrite this as tangent of 135 plus 30. So my A value would be 135, my B value would be 30, and I would be looking at the sum. So for this problem, I'm going to use the top formula. So tangent of the first plus tangent of the second. All over 1 minus tangent of the first, tangent of the second. Now use your unit circle to substitute in values. So what is tangent of 135? Well, 135, you take your y value divided by your x value. So some number divided by itself is just 1, positive divided by negative is a negative. So you're going to get negative 1 plus tangent of 30 degrees. If you look at your 30-degree angle, you're going to get y over x. So you're going to get 1/2 times the reciprocal. So it's going to be 2 over root 3. So you're going to get 1 over root 3, and you're going to rationalize that, so you're going to get root 3 over 3. All over 1 minus tangent of 135 was negative 1. Tangent of 30 degrees was root 3 over 3. Now, I could multiply by 1 minus square root of 3 over 1 minus square root of 3, but I first want to get rid of those fractions. I think it'll be a little bit easier for you guys. So I'm going to multiply the top and the bottom by 3, which really means I'm multiplying this entire fraction by 3 over 3 or by 1. So that's why this is allowed. So I'm going to multiply every single term in the numerator by 3. So this becomes negative 3 plus square root of 3 over, same to the bottom, 3 plus square root of 3. Now I'm going to multiply by the conjugate. I think it'll be easier now. And how do you get that? You keep your denominator exactly the same, except you change the sign that connects them, and then you put it over itself. And now we distribute. This becomes 3 root 3. Negative times negative is positive. So this becomes 3 root 3 plus 3 root 3, which is 6 root 3. Negative times a positive is a negative. Square root of 3 times square root of 3 is 3. Over 3 times 3 is 9. Negative 3 root 3 plus 3 root 3 is 0. Negative times positive is a negative. Square root of 3 times square root of 3 is 3. Condense, so you're going to get negative 12 plus 6 root 3 over 6, and simplify. This divided by this is negative 2. This divided by this, positive divided by positive is positive. 6 divided by 6 is 1 root 3. So this would be my final answer. Now I see tangent minus tangent on top, so I'm definitely not thinking it's a sum or difference for sine or cosine. And now I see minus, so I'm assuming it's going to be tangent of A minus B. Just to confirm, I want to look at this equation. Does it match it perfectly? Tangent of A minus tangent of B over 1 plus tangent of A, tangent of B. So I can rewrite this as tangent of 49 minus 23, and I'm going to get tangent of 26 degrees. I do not know what tangent of 26 degrees is without a calculator, so I'm going to leave it. Find the exact value of cosine of alpha plus beta if cosine of alpha equals negative 1/3 and cosine of beta equals negative 1/4, and the terminal side of alpha lies in Q3 and the terminal side of beta lies in Q2. What I want you to do is I want you to draw a triangle for the terminal side of alpha and a triangle for the terminal side of beta. The terminal side of alpha is in Q3 and the cosine is negative 1/3. I know r has to be positive 3. Remember, cosine is x over r. So that means the x has to be the negative 1. So then I find my missing side using Pythagorean theorem. So that's going to be 9 minus 1 is 8, square root of 8, or negative 2 root 2. So now I'm going to draw the terminal side of beta, and that's going to be in Q2. And remember, cosine is x over r. R is going to be always positive. So I'm going to choose a positive 4 for my r, which means the x would have to have the negative 1 on it, which makes sense since it's in Q2. Find the missing side using Pythagorean theorem. Why is it a positive square root of 15? Because I'm up above the x-axis. So then it asks me to find cosine of alpha plus beta. So I use my sum formula for cosine. So that's going to be cosine of the first, cosine of the second, minus sine of the first, sine of the second. Substitute in all the values you know. What's cosine of alpha? So I look at my alpha triangle here. Cosine is x over r. So I'm going to get negative 1/3. Find cosine of beta, x over r. So it's going to be negative 1/4. Minus sine of alpha, so it's going to be y over r. Sine of beta, y over r. Multiply, and then combine. For this one, I will not simplify any further since 12 does not go evenly in and there's no common factors with 1, 2, and 12, besides 1. Now the next two problems I want to see if you can try on your own. See if you can set up the triangle, find the missing side, are you in the right quadrant, and then use the sum or difference depending on the problem. So for this one, I'm going to use the sine difference equation. Alpha lies in Q3 y over r. Beta is in Q1, y over r. Find the missing sides. 25 minus 9 is 16, square root of 16 is 4. I'm to the left, so it's negative. 25 minus 1 is 24, square root of 24, 4 times 6. So that's going to be 2 root 6, positive because I'm to the right. Now that I set up my triangle, I just have to use the sign equation for difference. Instead of a and b, I'm just using alpha and beta. So then I've solved what I know. So sine of alpha, sine is y over r. Cosine of beta is x over r. Cosine of alpha is x over r. And sine of beta is y over r. And then multiply. They have a common denominator, so I can just combine as is. Draw your terminal sides in the correct quadrant and then find tangent of alpha minus beta using the difference identity for tangent. Sine is y over r, so this is going to be y r. Cosine is x over r, so this is going to be x and r. Find the missing sides. Double check your signs with mine. And I'm just using the equation from before. So tangent of alpha is y over x minus tangent of beta, y over x. All over 1 plus tangent of alpha, which is really just 3/4. Negative divided by negative is positive. Tangent of beta is just negative square root of 15 over 1. Simplify the top and the bottom. Now, before I get rid of the square root of 15 on the denominator, remember, I think it's a little bit easier to get rid of the fractions within the fraction. So I'm going to multiply by the common denominator on the top and the bottom. So the common denominator on the top would be 4, and the common denominator on the bottom would be 4. So if I multiply this entire numerator by 4, 3/4 times 4 is just 3. 4 times square root of 15 is just 4 root 15. Over, same thing on the bottom, 4 minus 3 root 15. See how these would cancel out on the second piece. Now I want to get rid of this square root of 15 on the bottom, so I have to multiply by the conjugate now. So I take the bottom and I keep it exactly the same, except the sign in the middle. And then I rewrite that on top. Now I'm going to distribute. 3 times 4 is 12. Then I get 9 root 15. 16 root 15 plus 12 times 15 4 times 4 plus 12 root 15 minus 12 root 15 minus 9 times 15. Simplify the top. 180 plus 12, 16 plus 9. Combine those like terms. These values are opposites. So I get negative 135 when I multiply, so negative 135 plus 16. And that's as simple as I can get. On your final exam, you will be able to have your Trig Identities chart in front of you. So you do not have to spend the time memorizing these identities. You can use the chart. So when you're doing your practice problems for this section, feel free to have your chart in front of you.